So now, having discussed about the neural network, its algorithms, backpropagation, different algorithms, we have normally used our neural network for in the context of binary classification. And we consider a typical example that we have examples of images where one class belongs to the images where there is a cat, another another class has images which have no cat. So cat and no cat, that was a binary classification problem. But now we want to see that how can we do a multi-class classification. So if we have more than two number of classes, so how can we use neural network for the classification in that scenario? So let's say we have five classes here, means we have a cat, we have a dog, we have images of bikes or motorbikes, we have images of car, and we have pedestrians. So let's say, so this first C is about cat. So cat, dog, bikes. So these are, so in this experiment, we have to class images, and these are five different classes. So how do we use neural network for that? So we will make a typical neural network. We will apply image here as an X and add the output layer. So that is an important thing that you need to understand, that the at each hidden layer we will have activation functions, but for multi-class classifications at output layer we have a softmax function. We have a softmax as an activation function. So what happens with this softmax? This is a softmax. I think it should be written like SK for kth class. So we have this capital K. We have total number of five classes. The value of capital K is 5, and this is softmax function. So how does it help for the classification in a multi-class problem? So let's say at this output layer we calculate Z1, Z1. Let's say it comes out to be 3. Z2 is 12, Z3 is 5, Z4 is -2, and Z5 is 4. So I have written these, arbitrarily written these numbers. I haven't calculated it on a particular data set. So these are just random numbers I have written here just to see the effect, how softmax does multi-class classification. So from this Z1, since we have to use the softmax function, so this Z1 means this Z1 is converted to e power Z1. So we will get some value, some positive value. Here e power 12, it will have a more positive value. So in the similar way, e power -2, it will have a fractional value. It will have a value like between 0 and 1, and then we'll have e power 4. So we will have different values here. So then how softmax calculates output? So each e value, that is divided by the sum of all e values. So in the denominator we have all e values, sum of all e values, all those values, and in the numerator we have e power z1, z1 that is related to this first output node. At the second node we calculate e z power 2 divided by the sum of all e's, and in the same way each output node is, the value at each output node is calculated. So then what happens, whatever the out values are at these nodes, at the sum of the values will be equal to 1. So if we calculate this one divided by sum of these values. So we will have, let's say, a value. We will have, here we can have b, here we can have, let's say, c, here we have d, here we have, let's say, e. So we have calculated different values. So all these values, they will be between 0 and 1, because we are normalizing numerator with the sum of all those values. So now we will see that which value, you can see here also that which value will be largest value. So because z2 is 12, so at node 2 we will have b will be the largest one and the other one will be smaller. All these values will be in 0 and 1. So b, it may have like 0.8, and all other values a, c, d, e, they will be smaller than 0.8. So because b has the largest value, so the neural network will classify this one as one belonging to one particular class. So if we are saying that the first node, output of first node is related to class 1, this one is class 2, class 3, class 4, and class 5. So since b is the largest value, so then neural network will say that the input x will be classified as class second, which is here dog. Yes. So in this way, Softmax performs multi-class classification.